everyone, and thanks for letting me speak at the Melbourne CocoaHeads. I've done Sydney a couple of times. I helped co-organize it, and we'd be happy to see you there as well. But it's really fun to be down in Melbourne for once and try to see if you're as welcoming to what I have to say as Sydney was. Today I'm going to be talking about server-side Swift, and it's one of the adventures that I've been going on recently, the past maybe now 3, 4, 5 months, because I have an indie app of my own that I work on when I don't work at Blue, and one of the challenges was that, as apps keep growing, we might need more capabilities, so there was a few things about the API provider and things that I wasn't really structured great for what I wanted, so I've had an idea for a while to go in and do something in between, and then I went down the road of trying it out. So that's often how things begin. We get curious, we want to see if we can figure it out. We usually can't, then we ask for help, and then we figure it out. So it's a bit of a success story, I guess. And I'm sure the same applies here. So we usually talk a lot about iOS or iPhone apps and iPad apps here, but we usually also focus a lot on what's happening on the screen. So today I'm gonna take you a bit on a journey behind the screen. We're gonna go a little bit further than that. So we're gonna end up in the server room. How many, just a show of hands, have thought about or already tried developing sort of backend apps or anything with Swift or backend at all? Oh, that's a few hands. It's good. It's good. How was it? Very good. Yep. PHP still works. It works. So I think that the first point is that many of the apps what we build today, we usually start the journey focusing on a single device or just a very specific use case, and I think we rarely stop there. So as the app grows, we want to do more things. We might want to incorporate or spread out to more devices. We might want to it just gets more and more complicated, and you might want to eventually move into sort of a more client-server based application. You might want to fetch data from somewhere or update data regularly. You might want to offload some heavy work to a server that can better handle it, or you might want to start synchronizing data between devices, and all that is going to require some sort of server, at least if you want to do it far away from the other device. So I think if you're building an app like a to-do or notes app or something with a camera filter app or even a game, then it might take a while before you need an internet connection. If you need it at all, I think you can go a long, long way without that, and you might even not need it at all ever. And sorry, I think a lot of the apps when iOS first came out, or at least the App Store first came out, started like that. Like they just were little fun apps like the beer drinking app on the phone. Like it didn't connect to the internet, it was just fun. But it worked. Like you can do apps that are fully functional without ever needing to leave flight mode. And that's pretty cool. And I might even say that, it's a pretty good approach to start your app thinking sort of offline first, because then if you do that, if you got that in place, when you start building networking and things into it, you add complexity. But if you enter like a slow network or a missing connection, if you build offline first, your app should already work fine regardless. So it might actually be a really good idea. Now coming back to this, so if you're building a game photo app, you might be fine. If you're building something like a weather or a stocks app, you probably want to connect to the internet fairly quickly to have any sort of use of it. It's unless you launch it on the day where the weather is perfect and you don't really update it, but yeah, that's not going to happen. So, and that's what happened for me. So I'm building. It also supports dark mode. That might have been a good idea here, but I'm also building an app. Sorry. Thanks to Coca-Cola. I'm building an app called Stocky, and as you can see, it's a stock and portfolio. It's generally an investing app, and one of the most basic features of that, obviously, is to go in and fetch the price for the latest stocks.
Tasty go.
All good. Yeah, so I can stand close as well. So I want to go in and update my prices and see what the latest price is. So as I mentioned right now, I get that from a third-party provider, but it comes with at least 2 downsides. Wow, that is amazing. So first of all, the data that I get is not always structured in a way that makes a lot of sense for my use case. So for example, sometimes I might need to call, in order to fetch information for a company, I might need to call 4 or 5 different APIs to get all of the information I need. And again, adds complexity, it might be unnecessary. So by putting something in between that sort of proxies that information, we can save a lot of complexity, we can save a lot of requests and performance as well. Secondly, I've got a lot of reference APIs that just returns all of the stocks in the whole world. And that doesn't change very often. So I don't want to spend my API credits for every user calling that, loading a massive amount of data and using up my credits. That can get expensive pretty quickly. So again, I've thought about setting up like a proxy or caching server or whatever you want to call it in the middle to handle all this. And I finally got down the journey to try it out. And I've done it, so it's running live as we speak. And yeah, it's working well. Is there something I should be aware of?
No.
Okay, good. I'm definitely no backend guru, so my knowledge here is limited, but I've known enough, have enough experience, and had enough experience with Swift to get something up and running. And luckily, I feel Swift is becoming more and more widespread for server development as well, and especially for indie developers or very, very small teams that might be low on resources. It can be a really great way to build on top of your product without having to hire a lot of extra people that knows just that. So definitely can see a lot of use for it. But why Swift? I think quite often we see that servers or backends are built using entirely different languages, entirely different technologies and tools than the app that might call it. And as I mentioned, it requires to do more work, it requires more people. So being able to using Swift, we can really, bridge that technology gap. We can have a much more similar environment across our entire tech stack. And that helps, we've got people that know both. It helps when we want to review code, fix problems. Generally just in the whole development cycle, we don't need to reach out to that specific person that knows just that one thing to get back up and running. And to quote the Swift website, the goal of the Swift project is to create the best available language for users ranging from systems programming to mobile and desktop apps, scaling all the way up to cloud services. This is impossible. It's pretty clear to me that Swift was created with the intent that it should be a language that is available on all platforms, or at least as many places as possible. I think even embedded, you can use Swift now. It's really powerful. And I also think it makes a lot of sense. So first of all, it's a really popular and powerful language. And it has few limits. It's a language that we already know very well. And as I mentioned, it's going to help because it's going to be super quick for people to get on board doing something different, changing up the way they're working, if they already know most of it. Swift is relatively new, and it is built by sort of taking the best bits of a lot of other languages. So it's quite refreshing. It's quite stable. It's safe is subjective, of course, but it's quite safe in terms of you can get the compiler to help you with a lot of things. I'm going to come back to that point. And again, using Swift for our entire tech stack, that's probably the top seller here, allows you to reuse so much code. You don't have to duplicate your models from the app and the server and all that. There's a lot of reusability, and you can also then test that one place and make sure that it works. And good for us, that's beginning or starting. It's really easy to get up and running. And that's what we're going to go through today. So if you want to try to push this in your business, there's been a few studies that generally show that Swift is a really performant language. Uses less memory, less CPU than a lot of other languages. And generally, that's going to result in a need for fewer servers. And that's going to lower cost. That's quite simple. As I mentioned, Swift is built with safety in mind, so we can sort of know that a string is a string, and when you plus it with a number, that's going to be not possible instead of returning a Boolean. So I think compared to some other languages, we get a lot of help from the compiler to help us build some safe code that breaks before it reaches production, so to speak, so we can fix it early. And again, using the same language means we need fewer people that can do more things. There's also been a study that tried to compare, again, the performance of Swift, but focusing on how it then would, like translating that into energy. And Swift is kind of ranking averagely, I'd say, but it ranks a lot higher than a lot of the common backend languages that we see now, like JavaScript, TypeScript, PHP, Go, etc. So by using Swift, we might also be able to do that a little bit more to save the planet, and that's good, I think. So let's get started into how we go about doing that. The framework I am going to focus on today is going to be Vapor, and it's one of the. There's quite a few frameworks out there. I think there's one just launched called Hummingbird as well. And I haven't looked into that, but I'm sure they're all mostly the same. Maybe some of them are more specifically suited for some purposes. Not sure, but I think Vapor is really good and easy to get started with. Generally, a web application just exposes REST APIs. So you're gonna have your app, you call some sort of web service via some APIs, and then it helps to compute or return data from you. And you can do pretty much anything you want. It's just going to be a Swift program like anything else. You've got access to the full suite of the language, the foundation frameworks, all the packages out in the community. It can be really, really powerful. And Vapor itself is, obviously built in Swift, so it's gonna run great on Mac and Linux and Windows, and it's gonna make it easy to, deploy on a server, so you can access it from your app. The way we get started is a Vapor application is really just a Swift package. And we're going to go ahead and open Xcode and then create a new package. It's terrible. You can either go ahead and create this separately, or you can go in your existing project and add it to there. It might be easier when you're just getting started to just keep it together, and you can always take it out afterwards. So I could probably recommend doing that as a start. And essentially, to make the package into then a web application, you go in and add Vapor as a dependency, which allows you to use their APIs and create what they just call an application. And then you can set up your routes, or basically your endpoints, and then you're good to go. So if you've got a package.swift file, it's going to look like this. Or at least you're going to have the dependencies. So you go in and add Vapor as a dependency, either via Xcode UI or just in the package file. And you're going to see something like this. So you'll see that we've got on the top, you got Vapor, the Vapor GitHub repository added as a package. And I'm using version 4 and above in this demo. And then you're going to go ahead and define a executable target. And in this case, I'm building a server for Stocky, so it's called Stocky server. And you'll see that I've got a Vapor as a product dependency there as well. So that's really all we need to get started. Your server app is this, that you don't need more than that. So basically, you go in ahead and create a struct, call whatever you want, my Stocky server I've used here. and you're gonna add main, so that's gonna be your main entry point. You're gonna have a main function, and in there we're gonna initialize an application. Then we go in and set up a get route with an endpoint called greet. So that's gonna translate into opening, an URL /greet, and then you can return some information from there. And that then uses the greet method, which handles the request and returns some sort of data. We also set up a post route. So post will be used to send some sort of, or submit some information. And here we've got an echo endpoint that goes down to the echo method, where we go in and fetch a value from the body, pass it as a string, and then we go from there. Wow. And for this example, that's all it's all the code you need to have a functioning server, actually. Like, obviously you're gonna have something that's a bit more complicated, but this works and this runs. You can go ahead and click the play button and call your server. That's all you need. From your app or from your calling code, you could then go in and define a server client, pretty common, where you can define a base URL, and you might have a method that you can call greet. And it's pretty standard, API URL session code. You append a path, you go in and ask URL session to fetch some data, and you get back a response. We try to unwrap that as a string, and then we can return whatever response we got, or throw some sort of error if that didn't go as well. But obviously, usually we're going to work with some sort of JSON data, and that's perfectly doable as well. This example just, expects a string, but you can add a single line. You can handle any sort of JSON codable result. It's really easy. And then we could imagine that we've got a Swift UI view that, updates some a label based on the response we get back from the server. So here we've got a simple view with the text, and we've got the content of that text attached to a state. And then we can go in and add we can add on a task on that. So we're gonna have an asynchronous task. We go in and create a new server client. We call the server and await the result. And then we go back and update. We update that state based on whatever we get back. Or again, we might show an error message if that didn't go as well. So let's say our server is set up to just return hello when you call greet. Then you should, when the view loads, after a couple seconds, just see the text hello. So it's really, really simple to get started, and you don't need a lot of code to get this working. And actually, when we look at apps today, you take something like Twitter, it looks really, really complicated. Like, there's a lot of things going on, and don't get me wrong, there's a lot of APIs down there, but at the very, very core, it's basically just saying, hey server, give me some data. It fetches some data, it shows it. That's what's gonna happen. So let's get a bit into more detail on what exactly I do. So first of all, I'm gonna create some models that I need to, or that I expect to get back from the server. So usually when we send data, it'll be generally like a JSON string essentially, or something, or encoded as data. But what we get back, we need to understand and be able to pass that JSON we get back, and there we use some Codable structs to be able to pass that. So in my example, I've got a symbols response that represents like a stock. It has a symbol, what exchange belongs to, a date, currency, etc. And it could be like a model for a stock exchange, same principle. But the thing is that both our server and our app needs to sort of understand what those are. So that's what you're gonna see. You'll probably see that these models will be duplicated in both the backend and the front end. And that's the first warning sign of something we could try to optimize here. But generally, that's what you see. The added thing is that, on the back end, it's going to be written the same model in a different language, but essentially it represents exactly the same thing. So in my app then, I go in and my server looks like this. So it's called Stocky's, we start in the Stocky server bootstrap, which defines that main method. And here, like before, I set up, I create a new Stocky server. What's a struct? It's not an object, but instance, I guess. And then I call bootstrap in that. And essentially, the way my server works is I store data on disk. So when I sort of load it up and initialize, it just loads that from disk into memory, and then it's able to return that over the API. So it's pretty much just static data I need right now, and that's perfectly fine. So this works for now. Yeah, and then I go in and define two endpoints. So they're both GET requests, and you might notice that here we've actually got two strings. So the first one will say app get and then v1 and then exchanges, and you can actually put in as many strings as you want. So each string will just be like a / parameter. So if you want to version your API, you just add v1, then you can have /exchanges /us whatever you want. So it's super easy to expand on that from there. And as before, those call respectively server.exchanges and server.symbols. And then you'll see those on the right, where I basically go in, handle that request. We'll take the top one. I go into my storage, load the exchanges from memory, and I wrap that in a response object. And then I return that back to the call side. So again, really, really simple. Not a lot of code is required here. And this is basically how the only code that's needed for my server right now. This is what's running in production. Like, it's not a lot, but it serves my purpose. So again, it doesn't take a lot of effort to build something that's working. But coming back to these responses, the Vapor framework, it essentially builds on top of Codable again, but it defines its own sort of content protocol and I'm not too sure what goes on underneath that, but it basically makes sure as long as a struct confines the content, Vapor understands it, it's able to read it, pass it, return it back, all that. So, and because my endpoints are meant to return like an array of all of the exchanges in the whole world, I just want to wrap that sort of I've got an exchanges response that basically has a parameter with an array of exchanges. So it's, again, super simple, but suits my purpose and it works. And that's really, again, all that I need. So of course you can also handle like post, put, and delete. We'll take an example here where we've got a post with a URL /v1/me, and then in the body or in a parameter you can pass some sort of data. And there's two ways. There's actually three ways that Vapor can intercept it, but there's two ways that you can get it out. And one would be via passing it in via a body payload. So let's say that this method takes a name. You could then go in and fetch that out of the body as a string and then return back, good to meet you, Dan, for example. Likewise, you could fetch it via parameters. So like query parameters. So let's imagine you've got the same /me, and then you've got that question mark, name equals your whatever. And then we can go in and get that out and say, good to meet you, Maria, whatever you put in. So that's just an example of a really, really simple post request. Of course, anything, if you want to go down and do something in your database or fetch some more, or like all of that happens in there. But at the very surface, this is sort of the interaction between what the server receives and what it sends back. And the same applies for put and post, for put and delete. All the changes really is how you handle it internally. So we've got a server going, and we'll try to run it. So if everything sort of first of all compiles and everything is done right, you can go ahead and call your server. And Vapor is pretty cool. So when you run the project, it's gonna set up a local web server that you can use for testing. And then what I could say is, the easiest way to get started testing that is to open your terminal and use curl, for example, or just open your browser, use Postman, things like that. And then you can go in and say, I think the default is like, localhost 8080/v1/hello, for example, and that might return hello CocoaHeads. Woo, okay. Well, I tried. Likewise, as I mentioned, there's like sort of 3 ways you can pass in data. One of them is via a parameter, so it could be like me, name equals Craig. And you can also use, that's just sort of curl ways you can do --data Craig, or you can pass in sort of the full JSON spec and go from there. So it's really simple to test out what you're doing with that. Now, in my case, I'm going to return a little bit more data than just that. So, but it's still the same, works the same. It just returns JSON, and you can get as much as you need. And that's it. We've got a functioning server. It's not that it yet, but we're done with the server part. But thank you anyway, though. I would like to demo it, and I did actually bring a special guest to help me out with that. Craig, do you want to give us a look?
Let's set the mood.
Too much? No. Yeah. Just gonna drag over a few windows, and then I should see it on there. Wow, excellent. Nice. Good, okay. So just to go through, it's the same code as we've just been through, so I just want to add a few more things, I guess. This is, again, essentially the code I've got running on now on my server. So as before, we've got this main method. We set out the bootstrap. I've added a couple of demo endpoints, as well as the 2 you've seen already. And then I've set up what's called an event loop group, which is essentially a scheduled timer. I don't know why it needs to be so verbose, but sure. And that basically means that, well, the way my server works is that I cache the data locally, but I do want to refresh that from my provider once in a while. So every month or so I go down and I go out and I try to request and update all the data I've got stored, but whenever my server gets called, it just returns what's in memory. So what this essentially does is that when my server boots up, it delays for a few seconds, and then it goes ahead and refreshes the data, and then that repeats every 720 hours, which should be about a month, roughly. So, details. As mentioned again, I've got my Stocky server, and it's got those 2 methods from before. We've got a hello and we've got a user. And we've got the exchanges and symbols, etc. And then enter some sample code and well, not sample, but helper code. My storage works like the same. So as I mentioned, because my server is preloaded with some default data, because I do go out and fetch it and update it, and then I sort of override what I've got locally with that. But in case that fails, or on first boot or whatever, I have preloaded it with some default data where, yeah, if the request fails for some reason, we don't just return an error. We've got some maybe old data, but still something that's actually usable. So that works for me, and that's sort of how I've set it up. The way I do that is that when I've got my server bootstrap method here, and that goes into my storage and then loads exchanges and symbols, which takes us over here. And here you'll see we've got a load exchanges and we've got a load symbols. And essentially it just goes in and loads the file from disk, decodes it, puts it in memory. It works for my use case. And likewise, when we do update the data, We go in and save the exchanges and the symbols to disk and reload it, and we're good to go. So it's a really, really basic setup, but it does the job for me. So let's try it out. So we click the play button to run it, and you'll see then when you run, if it goes well, that Vapor will, let's get that one out of the way. You'll see that the server has started on this address that you can then query. So let's go ahead and do that. I think I might have it on, no, that's fine. So we do curl, and then we go out to our local host. Oops. And hopefully that should work. Oh yeah, you're right. Well, live demos, eh? Well, I'm glad you're picking up. It was just a test. There we go. Oh, stop it. You'll also see in the log here that Vapor picked up a request to, well, several now, but it picked up a request to get v1 hello, and we got back hi CocoaHeads. So yeah, looks like we're working. We've also got the user, and then we can pass in some data, shout a name. Okay. We've got a creative one down there. Was it me? I think it was user on this one. Let's just check. It was me, exactly, yeah. And it's okay to make mistakes. We just fix them. There you go. So, thank you. I might, one of the really cool things is that, given that we've got Xcode and the IDE to use, we can also do full debugging. So when it's running, sorry, we can actually do full debugging. So while it runs, we could go into breakpoints and check, okay, we reached out there. Did we get out the right name from the body? Looks like we did. Okay, we'll move forward, and it works. So yeah, that concludes the demo. Let's get back to the presentation. Where did that go? What do you think, Craig?
How cool is that?
Yeah. I like it too. All right, so where do we go next? So as I've shown or demonstrated already, it is really good to start versioning your APIs from the very beginning. In case you got breaking changes or new things, people can easily, even if you're just yourself, you can easily add on things. And if you do change something that might be breaking, put it on a new version, you can sort of migrate your apps as you go. And it saves you a lot of trouble, especially once you've got a lot of users going and you don't want to, break production, essentially. Natural next step is to deploy it somewhere, probably to the cloud or self-host it yourself. You could even run it on like a Raspberry Pi if you are low on funds. It's an excellent way to start. You could always change and migrate later on. I do want to touch upon security. So obviously it's really good to sort of configure SSL, set up some sort of authentication or just an API key or some way of not making it too public. If it makes sense for your use case, then you might want to set up a database, read, write from that. You can really easily start to test it because everything happens in Xcode, so you've got all the unit tests, XC test capabilities. It's easy to, if you use async await, at least it's easy to create a URL session protocol, bypass the real network, test it. I think it's pretty easy. And most importantly, keep exploring. I found that once I sort of realized I can set up a server, there's a lot of new things that I thought, I can do that now that I really couldn't before. So you might get a lot of good ideas for your app if you give it a little think. And coming back to one of the sort of really low-hanging fruits, as I mentioned, a lot of the model code you have is going to be shared between the app and the backend. And because they're going to be, I guess, identical and written in Swift, both of them, it makes a lot of sense to take an hour or two now to sort of take that code, extract it out to its own package, and then make that a dependency of both, the other projects. Again, we don't want any duplication. If you update one model and the other one doesn't, you might break it. So I think it's a really low-hanging fruit. It shouldn't take a much longer, and yeah, it should be really simple. One of the interesting thoughts that I had, coming back to the exploring bit, is that I thought about doing UI testing and screenshots using my local server. So, for example, taking screenshots for my app for App Store. Currently, I've set up Fastlane that runs a suite of UI tests and takes screenshots as it goes. But especially, if normally those would hit like production data and the real APIs, that's fine. The problem is, at least for me, if you have screenshot that fetch stock prices, they might update every second, and it's not a great sort of user or marketing experience, I guess, if your screenshots next to each other have sort of different prices or different data. It looks strange in a way. I can't really put a word on it, but so I thought that I definitely don't want to hit my production server, both because it takes a while, it takes longer because we're leaving the network, much more unstable. But you've got a local server now. You can mock the data, you can return whatever you want, you can be sure that it always returns the same. I think ideally you'd want to basically mock it in the app, but given that UI test is sort of running in a black box, it's hard to sort of inject code or specific configuration. It's not as easy as it is with unit tests. So I thought about it. I might go down that road. I might not. I don't know. It was a thought. I'm happy to hear feedback on that if anyone has experiences with that. And I just like to point to a few resources if you would like to go further from here. So one of the inspirations for this talk was the one of the WWDC sessions from last year, and there's a lot of good references out references out there in the community. So there's the Swift website itself, there's the Vapor websites, there's the Swift server-side Swift conference in Copenhagen, and there's a lot of free courses, there's paid courses, lots of books. And if you do want to use Linode, for example, to deploy your server, Zach Simone from Sydney CocoaHeads has written a tutorial for that to deploy to a Linux server that I followed. Still relevant. It's super easy to get started with. And again, you can always go further from there. And second to last, I did want to mention a little bit of a bonus. So Swift, as I mentioned, is a really, really versatile language. I've shown that it can be great to build your backend with that, but there's also a lot of cool projects out there that revolves around, building websites with Swift, like, building static HTMLs, but generated from Swift code or Markdown. And I thought those projects were really, really cool. So back in 2017, I found John Sundell's Plot and Publish project. And that's basically how I run my website and blog and the Stocky site now. So if you would like to hear a bit more about that, then I'm happy to do a talk. So just reach out if you want. And that's it. Thank you so much for listening.
Thank you, Christian. Any questions? Right now.
Yeah, I'm sorry, I have two questions. First, how do you handle parameterized URLs? So right now you have static URLs, but how do you say, like, for example, /user/identifier, how do you capture that identifier with Vapor?
You mean like dynamic URLs?
Yes.
I'll be honest and go ahead and say, I don't know. It hasn't been a use case for me, so I haven't really given that a lot of thought. I'm sure, for example, Vapor allows that. But to be honest, I don't know.
I can probably answer that one. You just put a colon in front of the deep in the path name, and then it pops up as a parameter in the dictionary that you get from the request.
Oh, that's what you meant. Yeah. Yeah, so if I think you can. Yeah, they have. Yeah, you're right. Yeah.
And then quick question, where do you run your server?
Well, not surprisingly, right now it's on Linode. So I did actually start looking into Heroku at first because they had like sort of some free plans. They stopped doing that for money reasons, which is perfectly fair. And Linode, they just raised their prices a little bit, but they still have they give like a 1 gigabyte storage server, very, very generous sort of traffic limit. Probably talking terabytes or something. So, and it's $5 a month. So I think for not very much, that's gonna last a while, depending again on your use case.
Anyone else? No.
Hi, thanks for the presentation. I was just curious, from what you've shown, it seems like a very good alternative for server-side development if you are an iOS developer and you want to build a backend from it. I wonder if you had a team with an Android developer with you, would you still go Swift or would you go Kotlin for backend developer, given the structure?
That's a good question. I'm not sure if there's any Kotlin sort of server side. I'm sure there is, like frameworks like it. You could go either way. Like at the end of the day, what you end up with from the client side is just a sort of REST API. So no matter what you do pick, it's gonna work. For me, again, Swift is what I know best, so I'd probably go ahead with Swift. But if you're in a team, I think it could make sense. Or you might find that something like, Firebase also provides sort of a cloud solution, or you can do custom APIs with CloudKit, things like that, depending again on your use case. But yeah, I'm not sure if you can really answer that question unbiased at least. I would personally do Swift because that's what I can do. But yeah, I think you can do the same with both. I'm sure you can.
Yeah. What if your server crashes? How do you capture that information, that backtrace or whatever else? Like, how do you debug a production crash?
Also a good question. I'm sure Buck has a few insights on that. Well, you can. I haven't done it, which is my bad. So Linode itself provides, you've got full system access. You can check the log files and things. I'm sure there's a lot of sort of, crash frameworks again you can implement, or things like Datadog or various sort of logging utilities. Again, you can just in your server send data off depending on what you want to track. So yeah, I would probably go down that road. But again, haven't been there.